29 and 30. Copy what you can.
Industrial? I think that photochemical is something else small, and then the something else is industrial. Like car smog. No, that's not smog. No, that's the blue one. No, that's not photochemical. Photochemical is like the car stuff mixed with the other stuff. It's synergistic. There's sunlight that makes ozone. And then I know about the London smog.
Sulfur.
Yeah. The London smog is, or industrial smog is sulfur. Sulfuric.
But it's just right like the first out. I'll turn it off.
I tried to watch it. I watched it.
All right, students. Let's see here. If you were planning to buy an AP test, which I recommend, you should do that by March 26th. Technically, a lot of my students have heard about an extended deadline with a late fee, and they're like, I hate my mom and dad anyway, I don't care if it costs more money. But I should warn you that that extended deadline situation can create problems for you, the school, your colleagues. I would strongly recommend that you not rely on the extended deadline option. I strongly recommend that if you're going to get an AP test, you buy it by Thursday next week. Yeah?
The form to buy the AP test, you can get from the office, right?
I imagine so.
Yeah.
And I also have heard that you can actually pay on the internet, and then you just have to come in for the what do you call it?
Sheep.
The actual paperwork to select the tests. So you can get mommy and daddy to go to the site and pay and print the receipt. And then you just walk in with that receipt to the business office and you can do it all. Like, they don't have to come to school and you don't have to get something to take home. They pay on the web and then you fill out the papers here. Yeah?
Last year, I thought
You know, that may be possible. I don't. Yeah, like if you have your own credit card or something, maybe that makes it easier. I'm sorry that I don't know for sure what the deal is. Has anybody gotten it already this year? Do you want to give us any advice, any of you, about how to do this? Is there an easy way that I'm not thinking?
I just picked up the tree, got assignment for today.
Seems pretty easy.
I got the papers online and printed them in. But they said the papers were dated, so they only need to change that. But
Oh, the ones online are not entirely accurate?
and I think it worked. They had a newer format that makes more sense, I guess.
Okay. Interesting. So you can use the old ones that are online, but there's a different one in the office. Anybody else? Does anybody have solar house model questions? I know you've been working on it really hard. Yeah. I can't hear you.
Is there any other restrictions
Yeah.
besides no Adobe or Play?
There's some stuff written in the packet, like reflective materials on the outside, and I don't the Adobe and Clay. If you can figure it out, I'd love to see it. I'm just sharing the experience that years worth of students have been really frustrated by Adobe and Clay. Anybody else? Yeah.
You said that if we didn't do the geometry as one of our things originally, that it still has to be. What does that mean?
Wait, what did I say?
You were if you didn't do the geometry originally, you still have to do it or something.
I don't know when. I don't understand the context of this, so I don't really remember having said something like that.
If you do the geometry and 10 items, you still have to actually make it work.
Yeah, you'll still need to consider, how the light comes into your house
But you won't
differently.
have to have the exact measurements and math worked out. If you didn't do it originally.
Geometry is a required one. I think he's saying if you figure it out, you're gonna have to know the exact measurements. If you're taking that in, you're gonna have to kind of know the exact measurements.
How about this? When we test your solar house, we're going to have a sun here and a sun there. They'll be set up on this thing by about this week sometime. Because you're going to have those two different lights, you still need to at least plan on that for your house to work well. If you want to make it one of the points that you'll be testing that you could got credit for, then you have to show me the exact math so that I know that you planned it around that angle and length. If it's not one of the variables that you're going to be testing in the experiment, then you don't need to prove that you exactly measured the angle or the length, but just for my advice to you, your house will work better if you're at least kind of in the ballpark.
Okay, that makes sense.
I moved Tuesday's homework assignment. If you copied it, I don't know where it's going to land yet. So for Tuesday's homework assignment, the one that goes here, it's been moved. I still don't know where it lands yet. No homework tomorrow. I thought I would show off my Sunday.
What was Tuesday's?
We got a couple that finished with my friends yesterday.
What was the homework due Tuesday?
I think it said
It was a lab.
ozone sensors and particulate collectors.
Oh, okay.
It was?
I think it was still be
All right. So I guess we should get our class started. Did we talk last week about number 28, the 6 criteria of pollutants and stuff?
Yeah.
Yeah? So today we're going to talk about some chemistry that you have to know. Now, here's the thing with chemistry on the AP test. Because it's not a chemistry class, they don't really test you on the chemistry. Like for me, I've had high school chemistry, AP chemistry in high school. Then I took chem and OChem at my university. And I've had classes that have some organic, some biochem in them, but I didn't really take a strictly biochem series. So whenever I see chemistry, I can look at that and go, yeah, I can probably imagine why this happens, but I don't necessarily know how to explain it. So a lot of times, like, I just have to memorize, like, what was the formula for sulfuric acid? I can forget that. I can pretty much explain that one. I can't necessarily explain all the chemistry I know in APES. And you don't have to explain it either. In other words, please look up. It's fine if you skip some steps and don't balance your equations, because this isn't about the details of the chemistry. What you need to know in APES is what are the reactants and what are the products, and then more importantly, why it matters. The sort of stuff you got to do on the AP test is see this and be like, oh yeah, okay, so transportation and global warming and coal, and like, oh yeah, that's probably some car stuff, and you've got to be able to like place this into a context. Here we go. First of all, number 29, acids and acid rain. I got some notes for you, and then some mandatory chemistry. Please look up. The mandatory chemistry is how to make carbonic acid, nitric, and sulfuric acids. In case you haven't written these down and you couldn't read my chicken scratch, I'll just read them really quickly. CO2, H2O, H2CO3 is a weak acid. pH is roughly 5.5. NOx and water make HNO3, which is a strong acid, pH about 4 to 5-ish. SOx and water make sulfuric acid, which is very strong. That pH is between 3 and 4. Anybody have questions about those reactions? Yes? Nitric and sulfuric. Anybody else? Yeah.
Didn't they say that acid rain could get lower than those pHs?
Maybe a combination of the acids or something. Maybe there's other ingredients in extreme acid rain that I'm not including here. That might be a good guess. But these are the main acids in acid rain. There may be others. And they said in the book that pH gets below 3?
Yeah, they said it could be between like 1.8 and 5.
That surprises me. I didn't know that. Okay. Next. Key reminder number 1. All rain is acidic. Because we've always had CO2. It's not extremely acidic. 5.6, that's not that bad. That's not going to burn your eyes. That's not going to melt your skin. That's not going to take away the enamel from your teeth. That's not going to kill your cat. Key reminder number 2. It's not just rain. There's acid hail, acid snow. We even get what's called dry acid deposition, where fog or rain will happen up high, and then they evaporate into dry acid crystals that just drizzle down. Fun fact for people who are into nerdiness, probably the worst of those is the snow. Because it all piles up until it all melts in the spring, and then you get all of that acidity flowing in a single hit of snowmelt. So you can basically accumulate 3, 4, 5 months of atmospheric acidity in snowbanks, and if they thaw very quickly, that's a whole bunch of acidic runoff. Apparently this is one of those reasons why, like, a lot of those industrial cities that are far north, like the Great Lakes cities, a lot of like northern Russia and stuff, that's why people call them like rust belts, because not only is there a lot of water, but especially with all of the industrial chemistry there, you get a bunch of acid snow which really eats metal. Next little reminder, acid rain is not especially harmful just on its own a little bit. Like, if you get a little squirt of lemon juice in your eye, you just blink and cry a little bit and it's gone, you'll be fine. And that's pretty acidic. If you like throw up because you got the flu or something, you know, like that stomach acid in your mouth is not a pleasant experience, but you rinse it out, you'll be fine. The important variable to remember when we talk about acid deposition of any sort is that it's repeated. It's an ongoing or cumulative problem. Cumulative problem. And here's why we care. 5 problems. Microbes in the soil. And everybody understands how important that food web in the soil was. We've talked about this a million times. If you kill the microbes, you kill the dirt. Number 1, soil microbes are really easily affected by acidity of their soil. Especially if it's like a long-term shift of soil pH. Number 2, the aquatic species, remember I told you before, the ones that breed or breathe in water. Number 3 is 2 parts to this issue, so we got to be really, like, the first part of the issue is when rain gets more acidic, rocks weather faster. Everybody understand what I mean? That rocks weather by rainfall, and acids make them weather more quickly. They dissolve more fastly. Separate question is, do these rocks have something hazardous in them, like heavy metals or toxins? Because now, if they do, acidification accelerates dangerous weathering. Let me clarify that dangerous weathering part. If Santa Barbara had accelerated weathering, what would happen to our sandstone hills? They would wear away faster and we'd get more sand on the beach. The end.
So in the future, Santa Barbara is going to become one huge beach with a mountain to the road.
I mean, there's a lot of other variables in the future that you're talking about, but essentially you could say that about all mountains on Earth.
Possible.
All mountains will soon be sand. Everything in the sea is becoming land, and the land is on its way back to the sea. If Santa Barbara has accelerated weathering, our sandstone will fall apart faster into sand faster, and we will get more sand more faster. But what if Santa Barbara had a band of cadmium in the sandstone? Our usual rate of weathering would just have a little bit of cadmium in the runoff, but understand, this is the tricky part for number 3. For number 3, here's the tricky part. If you had dangerous cadmium in our rock, more weathering would elevate cadmium levels because there would be more of it in our runoff at once. Does that make sense for everyone? So it accelerates dangerous weathering. In other words, it raises the concentration of dangerous elements where they are found in runoff. So if you have a little bit, acid rain will make more of them because the rocks are wearing out faster.
So is it a positive feedback?
No, not necessarily, because those dangerous things don't necessarily make more acid rain. Number 4, acid deposition ruckuses building materials. Steel, concrete in particular, marble. Paint. Basically, metal and masonry. When I went to go see the David, I stood in line for like 4 hours, and it was like sweltering heat. And I just like sitting there like standing in line with a bunch of Italians and random foreigners. Like nothing happening with my like sweaty mom and dad that were fighting the whole time. And eventually they like let us around the corner. And I'm like, oh wow, plywood shack. I guess we gotta do some sort of security check. And I walk into the plywood shack and I'm like, that's the David. And I couldn't believe that the most like spectacular and precious work of sculpture in the history of the sculptural arts was in like a friggin' plywood shack. And I'm like walking around like looking at the David like this is the most majestic thing that's ever been made, and it's in a plywood shack. Like literally there were like what do you call it, pigeons like roosting on the edges, like crapping on the floor. And I was like, this is the most low tech, low security. Like I visit a lot of museums because my mom's into art, and so like I've seen a lot of like famous works. And literally, like, there was, like, trash, and, like, what's going on here? And as we were leaving, there was this sign that somebody had to explain to me, because it was in Italian, I didn't understand what they were talking about. Like, please excuse the quality of blah, 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 it has recently come from blah, 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 that accelerated acid deposition in the region of Florence, it's Florence, right? In the Florence region has been harming the David, and so we had to cover him. And and they show a picture, and you guys know that the David has like wavy hair, like curly wavy hair, and they had a picture from above, and he had like all these little pits, as if somebody had like drilled holes in his head. They're like significant. Apparently what happens is when acid rain lands in a pool that can't run off, just like salt, and you guys probably understand where this is going, the water evaporates and the acid leaves crystals. If you get a big old rain, that'll flush out, but you're leaving a little tiny bit in there. The danger is when you get just a few little, like a drop, or like a little fog that'll just rehydrate, and then it evaporates again, and then it'll rehydrate and evaporate, and every time you're adding more acids, right? You know what I'm saying? So you get acid etching, where acid will carve its way into stuff. Apparently, like sky rises and towers and big bridges, if you have acids, they will just start to carve their way into any flat spots or indentations at the top. Yeah?
Isn't the David inside of a building?
Yeah, they had him outside because of like some, they were moving museums or something, changing the museum. He's back inside? I can't remember what the deal was. There was like a whole bunch of hassle. Maybe he was on tour. Yeah, seriously, no. I am not an expert on these details. Yeah. It's been many years. It's probably been maybe 15 years.
Whenever you see pictures of him online, he's in that room that has like the glass, like the window.
Right.
Yeah, that's where he was.
I don't know why he was outside.
What did you see, Jose?
Yeah. Maybe it wasn't the David?
No, it's not it.
I don't remember.
Yeah.
What's his hands so big?
His feet. Number 5. This is the part that you all care about. Acid rain is bad for you, and it's bad for me. But it's not like it's going to blind you or melt your skin. You're not going to die, no matter how much you get. The problem is when you breathe it into your lungs, especially if it's being carried by particulates. So acids can be dangerous for your respiratory system, but if they get stuck in place by particulates, then it's really, really dangerous. Like really, really double dangerous. And that's essentially what happened in London 1952. In London 1952, please look up, there was a bunch of really aggressive transportation because London was trying to rebuild after World War II. So they had all the trains running, and they had all the boats running, and they had all the cars, and it was 1952, so the cars were crappy, and they had all the trucks. And London was just hustling to restore itself. This was their baby boom. So London was like in the middle of like citywide rebuild. And they were probably in the middle of nationwide and region-wide rebuild. So they had, please look up, tons and tons and tons of transportation plus tons and tons and tons of factories and industry all at once at an unfortunate perfect storm of the right atmospheric conditions with a lot of fog in the water. So basically what London had was the really extremely low pHs, mixed acids, plus from all of that coal, they had lots of particulates. So people were breathing ultra-fine, the small coal particulates, ash particulates, and that was delivering all the acid into their lungs, where they basically had like a pasty cake of acidic ash powder. Today, this is possible in any industrial or urban area, but you should know that most modern cities keep these ingredients out of the air. Nowadays, we use filters to limit this. nowadays, all those oxides get captured. Especially the SOx and the NOx. So this is kind of a past tense problem. Anybody want to ask me about number 29? Yeah.
So like in like Santa Barbara, if we captured a bunch of rain and then we pH tested it, what would it come out to be?
My hunch is it's about 5.6 and yeah, it's probably less than a lot of CO2. And I guess that's a really easy experiment any day now. You don't have to rain. All right. Would anybody like to talk more about number 29? Because I'd like to move on. So here's the answer to your warm-up. There's two types of smog. They are the the London type, which is gray. It comes from sulfur. It's basically coals that make acids, or it's primarily coal that makes acids. You know, like this. This is the sulfurous kind, the gray kind, the London type. We still haven't talked about this one, the LA type, which has that characteristic brown orangish kind of color, also known as photochemical because it's chemicals in sunlight. And it's mostly cars that make oxidants. I need 3 students for a demo. Who will be my 3 students? Any 3. Hurry up. Any 3. So boys, you saw that I was fishing. I don't know if you noticed, but I've been putting lotion on my hands because I'm all chingered up. Handling the fish. I had to go on the picture too, so. Thank you. Actually, I'm sorry, I lied. Holger was absent. Hey, Bodie. Alright. So, boys, I apologize. I swear it's just lotion. I just washed my hands in past periods. Alright. Everybody in the audience, has anybody heard of Hofbrinkel? Hofbrinkel. Yeah, other than being right there on the board, you've heard of it? Everybody must write in like the margin or the top of your notes, Hofbrinkel. Big H, big O, big F, big B, little r, big I, big N, big C, little L. Yeah. I don't care, you're going to need it a lot in the next few days. Yeah. It's a little L at the end. Who knows what Hofbrinkel is? They are 7 elements. What's 8 elements? 8 elements. And what's special about those 8? 1, 2, 3, 4, 5, 6, 7 elements. They are not all oxides. At this point, they're just elements. Oxide is when you stick an oxygen to something. What else about them? Okay, fine. Check this out. They are what we call the diatomic gases. Write down that term, diatomic. And that means you will never, ever, 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 ever find them single in chemistry on our planet. They are clingy, so you will always find them in couples. Like this. Okay? Being a clingy single, I'm sure some of you understand what I'm talking about. You know desperation. Yeah, you're adolescents. Unless you happen to be amazingly beautiful, you know desperation. And so, we write hydrogen gas as H2, we write oxygen gas as O2. All of those, the Hofbrinkel 7, you always write them as 2s because they're diatomic. If something were to happen where bonds are broken, we will immediately run back to each other because we cannot bear to be alone. I cannot bear to be alone. Cedar cannot bear to be alone. Everybody understand what I'm saying? Now, this is a good, strong bond. I think. We are pretty much inseparable. But the atmosphere, I think you remember, is a dangerous place, especially if you go up high enough, because there's the ultraviolet. You might remember we talked about that at the beginning of our unit, right? And so, things happen, and, you know, things happen. Okay. And so maybe ultraviolet, maybe some sort of ionizing radiation, maybe, I don't know, all kinds of crap I don't understand. Maybe we really do break up, and if we find some way to be satisfied before we can reunite, I gotta peace out, bro. I just couldn't be single. I was looking for you and I couldn't find you, and you know, she was around, and like, bro. So you can see I'm good. But what's homie gonna do if there's this oxygen right there?
Am I going to bond to them, or am I going to split them up and bond to one of them?
Well, what do you think?
I'm going to bond to all of them.
Yeah! That's ozone right there. Okay. Now go ahead and be ozone for a minute. No, come on, be ozone for a minute. You can link arms if you want. That might be easier. You can hold hands, like real men. Oh no, we don't hold hands. This is America. Okay. I don't know if you've ever been in this position, but you're out on a date and things are looking really good and you're like, you know, this might work out. Take a quick little, what do we call those? Hand sink bath. You check your breath. You're like getting the butterflies in your stomach. Oh my God, this is going to happen. And then you run into your scumbag loser buddy. And it's like, I just got dumped. I can't be alone right now. It's just too hard. You know what I mean, the third wheel? How many of you have had a third wheel somewhere associated with your dating life? Oh my God, you're all lying. Okay, fine. Well, maybe you've seen it in the movies. I've been there. And you have like your pity third. Where you're like out on a date and it's like, oh, Betters, you didn't, okay, fine, you can come with us, I guess. And I guess if you haven't had the experience, maybe you don't understand how awful it is. Where you know you can't leave them alone because they're all depressed and pathetic. But you know you can't keep dragging their sorry asses around because they're wrecking your potential. I have, if you ever want, I could try the bonding strength OChem electron geometry answer. But I'd have to check some notes and I'd probably fumble it because I haven't used that stuff in about 20 years now. The better answer, for you to just understand the concepts, is imagine that all three of them would rather be in a couple. But none of them wants to be alone. So all three of them are hoping that one will leave. We call those oxidants. Things with an extra oxygen. James Mel, if you're checking your cell phone, I want to blacken both eyes. Here's why oxidants are dangerous. in biological chemistry, in your body, there are a variety of receptive chemicals that are useful to the functioning of you. In your blood, in your respiratory system, especially in what we call your, maybe worth writing down, your mucous membranes, like the parts of your body that are open to the air, the thin spots in your organism, the weaknesses in your skin. Your mucous membranes have chemicals that are, they're there for bonding. And imagine if you bring an oxidant around, they're kind of, everybody's waiting for one of those to jump ship. So, imagine this scenario. Receptive guy comes around, what will the ozone do? And what will happen? Yeah! Now, I was an oxygen earlier. I've kind of rearranged my metaphor. Now I'm whatever. But look at what happened. In the presence of oxidants, ozone donated one oxygen that bonded with, holy crap. You're a bony little dude. You gotta eat more, homie.
I know. Too much.
You do. In the presence of ozone, any available bonding site will oxidize, leaving oxygen, which is now finally happy, stable. They're going to be oxygen for a very, very long time. Those are good, strong bonds. And now they can go do their couples thing. So, pretty much, anytime ozone comes around any available bond, it will oxidize it. You understand? Oxidize it? Boys, you missed that. Thank you. Good work up here. Good work. Now comes the part where you might need to interpret your notes, because what you wrote down is probably not useful to you. Please look up. The sulfurous stuff is acids. The La type is brown. We call it photochemical because of light and chemicals. Cars make those oxidants, and there are two oxidants we worry about. Please look up. Ozone is one of them. The other one is a group of chemicals, this is tricky, called peroxyacyl nitrates. And there's a whole bunch of them. That's not one thing, that's a group of things. Like STDs. Yeah, rubbing up against high school kids always makes me worried about that. Which I do all the time, of course, so I worry about it. Look. NO plus VOCs will usually make NO2. NO2 is not very strong in the atmosphere. It splits off a clingy single. That clingy single will find oxygen and make ozone. This is the standard ozone formation, which sucks because cars make both of those, and there's ultraviolet a lot. In other words, please look up. Car emissions in sunlight make ozone. That's why it's photochemical. Car emissions, sunlight, ozone. That's what I mean by interpreting the equations. Remember that at the College Board level, you got to know the car emissions and the sunlight more than the reasons why they bond. Yeah?
Don't we want ozone?
Oh, great question! Yes, we do, but not here. You know, like everybody wants a gun, but pointed in the wrong direction, not as good. Ozone is great up there because it blocks ultraviolet, and there's no humans to breathe its toxicity. Here, it's too late to block the ultraviolet, and by the way, it's toxic for us. Up there, all the benefit, none of the harm, Down here, all the harm, none of the benefit. You feel me, dog?
Yeah.
If there was a way to shuttle our waste ozone 30,000 feet into the air, we could kill two birds with one stone. Is that your question, right? Hughes? Is there no way to move it up there?
Yeah.
Yeah.
Just add helium or something.
Yeah, add helium.
At-
Turbo back there. All right. Now look at something else that happens with car emissions, though. This is potentially tricky, so if you don't speak chemistry, I'll just try to say this a few ways. But everybody has to stay with me on this. Nitrogen dioxide and reactive hydrocarbons in sunlight can make something which looks roughly like this. And if you speak chemistry, you probably haven't seen a description like that. CHOOONO2. That's probably more OChem level, I'm thinking. That might be AP Chem. Anybody take AP Chem here? All right.
We do.
Here's another way to think about it. Let me try it this way. Hydrocarbons and nitrogen dioxide will usually rearrange themselves so that the hydrocarbon has 3 oxygens attaching to that nitrogen dioxide. And if you don't understand, don't worry. We're not done. You can look at it another way, but please stay with me. What we're worried about is anything which has this shape, which is oxygens attached to an NO2. The reason we worry is when they attach this way, you get a loosely held oxygen, just like ozone has a loosely held oxygen. At the level that you need to understand this today, car emissions in sunlight make ozone and another group of chemicals called peroxyacyl nitrates. You gotta know that. Car emissions and sunlight make ozone and PAN. That's not too hard. You can remember that. Car emissions in sunlight make ozone and PAN. What, child?
Do we have to remember the exact equation for PAN?
I'd say the more that you understand, the better. The equation for PAN is not such a thing because there is no single equation for PAN. PAN is a group of chemicals which are basically a hydrocarbon, a string of oxygens, and nitrogen. And so the scary part is that string of oxygen creates a loose, so there are oxidants.
What's that not
What?
What's that not
In the presence of which we're about to make PAN. Remember, the reason we worry about oxidants is they really ruckus biological chemistry. Like in your case, they make your lungs feel like they're burning, they make your eyes burn. They cause scarring that's very similar to breathing hot air, like a burn. Anybody want to talk more oxidants? So those are the 2 types of smog. Now, we in Santa Barbara, we have cars. We even have a shipping lane where we have unbelievably dirty container ships. And anybody who goes to the islands has probably seen the container ships out there. I saw a huge one yesterday. Weird one. It's like a big old tub with no containers on top. It's the kind of they fill with grain. That was amazing. I've never seen one of those before. So we've got really dirty containers out there, container ships. We've got a relatively dense urban area with a lot of cars. We get rush hour here. But we will never have smog. Take my word for it. It's not going to happen. We don't get smog. We don't do smog. Yeah, we are too good for that. That's right, yeah. But why does LA and Denver and Beijing, Mexico City, why do they have smog?
Don't they have like mountains that trap the air?
Yeah, they do have mountains that trap air.
Ours, like, we don't trap it.
No, ours don't. Because there's one special secret. Anybody know what it's called?
The inversion there?
That's what it's called. That one. Okay. Now comes a whole bunch of knowledge in just 5 minutes. This is a whole bunch of knowledge in just 5 minutes. If you give me 5 minutes, this will make sense, but if I only get 3, it's probably going to be confusing. Look. That's what happens normally on the first study goal of this unit. What is the heat source for our atmosphere? The Earth's surface. So where is the hottest gas?
Nearest surface.
Nearest the surface of the Earth. And what does hot air do relative to other air?
Nearest surface.
Hot air rises, doesn't it? So wherever we make pollution, it rises away from us. See? Because it's the hot air taking it away. So you and me, we don't have to worry about this. Because you and me, we have air that goes that way. You and I, we have air. Everybody got that?
So our pollution is just going elsewhere, we don't see it.
That's right. And you know, it dissipates. So it's not like we're living in a dense cloud of it. But places like Los Angeles, they've got another problem. Aside from being Los Angeles, generally speaking, this is a perfectly designed death trap of the gods. Look at this. Look. Ocean, mountains, 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 and technically there's a mountain right there. So technically Los Angeles is in a bowl. Like Denver, which is surrounded by mountains on all sides, or like Mexico City, which is surrounded by mountains on all sides. And here's what happens there. When the sun rises in the east, you know, sun rises in the east, the city of Los Angeles is in the shade of the mountains, while the desert has already been heating up. Watch. You have to be able to explain this. Hot air rises and expands over marine layer coming in from the ocean. So watch the combo. Cold air in, hot air over makes this. One of those rules on the first day of class was heat is proportional to pressure. So pollution starts to rise and then gets held down by the hot air above. Does that make sense to everybody?
Oh yeah.
Yeah.
So I was sitting at the Wilcox property this weekend, and I noticed there was like a layer of fog that was exactly perpendicular, not perpendicular, parallel to the ocean. It was just one thick layer, about like 8 feet up the Channel Islands, and I was just wondering why that happened.
Cold air settles. So when you have just a mass of warm air, cold air will tend to sink. So basically, before sunrise, there was general fogginess. And as some areas heat up more than others, that hot stuff stratifies and expands and makes like a blanket that holds down the fog.
It was on a really hot day, too. So
You can imagine everything heated up a little faster than the Santa Barbara Channel. And so between the islands and the land, there's just enough shading and trapping where the other stuff sort of held in that layer. Look, smog makes a perfectly flat band. Because until the city gets hotter than that air, the pollution can't rise. Does that make sense to everybody? Until the city gets hotter than the air?
Yeah.
So in Mexico City and in Denver, the cold air doesn't come in from the ocean. In those places, it comes in from the high mountaintops. But here's your combo. Hot air over, cold air in. There you will trap your pollution in the water. In the daytime, you've got the sunlight. LA is screwed. They're all living in a perfect human killing box. We could have air twice as dirty as Los Angeles and still have less smog. Because here, we've got this open city plan. We don't have a bowl that traps the cold air. Our cold air can sink out, our hot air can rise and dissipate sideways. If you have a bowl of mountains that can capture cold air, like the tops of the mountains in Colorado or like the ocean, with hot air coming from somewhere else, then you'll get inversion layers. Those are the places that have smog. Yeah?
So why can't like LA's smog travel to like places close to it?
Because in other areas around it, you don't have hot air on top. Remember that all air pollution comes from land, so it wants to do this. You've got to have a place where it's trapped, otherwise it would dissipate. When you go to Griffith Observatory, you can look down at the smog, and this looks flat, just like the fog that Cedar saw over the ocean. It's like a flat layer, but that has to be contained by something. Otherwise, it will eventually rise away. You know, this breaks up. At 3 in the afternoon, the sun is over here, so now you're heating the city and shading the desert. You know, sunset in Los Angeles is always beautiful. Because by then, the city is hotter than the desert, and so this stuff has broken through. This has to be hotter than the city for it to trap. Most places are not. Most places have cooler air as you go up. So as long as you've got cold air above you, your pollution's going to the cold air. High low pressure. Yeah?
Is the reason that Beijing has got smog the same?
My hunch is, I don't understand the geography of Beijing, but there must be some sort of an inversion factor. Another issue, Bodie, is that they've got both types. Beijing is the double